Hello, everyone. Welcome to Cloud Currents, where we engage industry experts to talk about trends, tools, and strategies as they relate to cloud and innovation. Today, we're thrilled to have our guest with us, Huamin Chen. As a senior principal software engineer at Red Hat's Office of the CTO, he's focused on cloud-native infrastructure projects. Huamin brings over 9 years of expertise in open source technologies like Kubernetes, OpenShift, Ceph, Rook, and Native. Huamin is also a founding member of Kubernetes SIG storage group and a proactive contributor to multiple CNCF projects. He's also leading sustainability initiatives around energy efficiency and carbon footprint reduction in cloud-native environments. He is also involved in various startup companies working on storage, data security, FPGA acceleration, and hardware and software co-design. Welcome to the show. We're glad to have you with us today. Did that sound about right?
Yeah, Matt, it's my pleasure to meet you, and thank you for the introduction. That's really wonderful. It brings a lot of good memories to our mind.
That's awesome. So let's get started. Can you walk us through your career journey and how you ended up at Red Hat working on cloud infrastructure?
Yeah, my pleasure. So when I was starting my careers almost 20 years ago, I was entering this hard decisions of which is the best technologies at the time. The year was 20 years ago, 2003. At the time, the internet bubble was just busted, and where the industry is under the hard pressure. And I joined this company called EMC, and right now it's called Dell EMC. This storage company has a lot of advanced technologies. So I joined there. I started working on the storage system called High Road, which is hybrid file system that's using a lot of technologies in behind. So I was working on a number of platforms, including Linux and Unix. I found out that the Linux infrastructure has so much attractiveness to engineers because we can go into the kernels, ask questions in the community, get immediate feedbacks. I was kind of surprised when I was asking questions to Aaron Cox, which was like almost the head of the Linux software development. And I got answers right away. It's amazing. Now, after EMC, I spent a few years in other companies and I finally joined Red Hat. Finally, my dreams come true. I was able to meet so many wonderful people in the open source, and their personalities, they're open to questions and open to challenge is unparalleled. And I really like Red Hat so much. And back to the days when I was working at Red Hat, there's a number of interesting developments in the industry. As you already know, in year 2014, virtual machines, half of virtualization was kind of the state of art. But there was an emerging trend in containers, and that totally happens across the industry as a surprise. And I was so fortunate to join this wave of development in the very beginning. Now, when I was working on the project called Kubernetes, it's very little known name by then. It's now almost like a household name in many of the developers' home. But back then, I was so fortunate to be one of the few people who are working on Kubernetes and starting the storage stack from very early stage. And I was able to make a lot of contributions to the projects and meet so many wonderful and exciting community members. And that's why I got fallen in love with the projects. And eventually, the Kubernetes evolved into an organization called Cloud Native Computing Foundation, CNCF. And I was so proud to be a part of the organization and in the community contributing to a number of projects. First starting from Kubernetes, and then I started working on Rook when Rook was admitted at the incubation projects in Kubernetes. And I was also getting the chance to work on a number of projects before they joined the CNCF, like Knative, which is a serverless platform. And then over the years, I got a sense that the CNCF has so much enthusiasm embracing all the challenges that the industry is facing. It's taken a lead in many of the innovations. For example, the sustainability, which is the topic we hopefully can continue discussion for the rest of the hour. The CNCF is one of the earliest community to embrace environmental sustainability. There's a technical advisory group, TAC, on sustainability, started a year ago, and that's attracted so many participants in the community. And from that point, we were thinking, can we do something for the industry, for the community, and actually for our society? So what we do in terms of technology innovation comes in three fronts. So one of those things we call observation. So the more we see how much energy being used in our data center, in our software, the more chance we can take actions to make things go in the right way. We can use a lot of analogies. Probably one of the things we can use is like just the phone bill. It's not nowadays it's not a big deal anymore. But back in the days when we each one of you have the smartphones, what we care a lot is the phone bill, right? If your cellular usage goes out of range, you pay more. This time, especially when you have the family plan, you have multiple phones. And if you're wondering why I should pay this much for this month, look at the phone bill, look at your cellular usage. Wow, immediately you know somebody's phone is out of control. And then the next month you are taking actions to reduce the cellular usage and your phone bill will go down. So that's the same analogy we're using here. If we know how much energy used by the data center, by different tenants, different software, then we can take actions to say, bring the energy bill down, reduce the carbon footprints by shutting down this machine, by optimize this software. So that's the kind of motivation we want to start in terms of to have sustainable computing environments. Sustainable means two things: be efficient, whilst you continue your practice, not to means totally shutting down. It makes your life goals sustainable. So that's what we do. The second is we want data center to be smart. So we want to identify the opportunities that we can optimize the energy usage and carbon reduction in the data center by lots of things. There's different scheduling algorithms, scaling algorithms, that kind of thing we want to use. And very lastly, we want to make the software greener. Well, at the end of the day, you do not just power on the servers to run idle. You want to run software on it. The software is the critical piece that makes the data center greener. So how to make that happen? We want to bring certain metrics, certain tool chains to the software developers, so they can use these tool chains to benchmark their software to identify the bottleneck, to find out how they can use less energy to achieve the same thing. So that's one of the three directions we are exploring to hopefully to make our society, our industry go sustainable.
I love it. I love it. Very noble. And I know sustainability is a very important thing a lot of businesses and a lot of people in general are thinking about. It's not just within business, it's everywhere. Everyone's thinking about sustainability. So it's really interesting points you made in the focus. But I'm curious, before we dive more into the software, I'm curious as to what motivated you to start focusing more on sustainability personally?
Yeah. So I think the sustainability in a better way or in a personal way means frugality. I live in a very frugal life. Ever since I was a child, I was the second, child in my family. As when I was little, and our resource was very scarce. And as the youngest son in the family, you had to make a lot of struggles. Finding the better room, finding the fights on the dinner table to get more food, that kind of thing. So I realized, the resource is scarce. If we are not doing something to make things do, that's going to mean a lot of consequences in our life. When I become older and have my own family, my own children, so I'm just wondering, do we have enough resource for everybody? Especially when the child grow up, do they have enough resource in the future to live peacefully with their peers? So that's kind of a mentality coming to my mind on my day-to-day basis. So that's why I strive to make sure that at least I can do something to sustain our society, sustain the next generation's future. So they have a better, brighter prospects than Earth. They can live peacefully. They can live, resourcefully, with a lot of things, still with a lot of resources at their disposal, without have to worry about, the world will end. So in order to do that, we have to make sure that we are not waste too much. But that does not mean we should cut off everything they are used to right now. They can still do what they want, but can do it in a more efficient way, energy efficient way, environmentally efficient way. So they know what they do is consciously for the better goods, without have to sacrifice, making a greater sacrifice in their life quality. So that's why we are trying to get a lot of intelligence into our industry to make sure that what we do is can continue, but what we do is in a better way than before.
That's great. That's great. I really love how you put it with doing what you're doing, but doing it more efficiently, and not sacrificing what you're doing, and making sure you're thinking sustainably as you're doing it. Awesome. So let's talk a little bit about the initiatives you're working on. So can you explain some of the goals of the sustainability initiatives that you're leading at Red Hat?
Okay, that is my come to our work. That is going to be very interesting. So we currently have different roadmaps. The roadmap is to have one project deliver and continue the next one based on the previous ones, so that we can have a coherent story and that we can deliver for the future. So the first project is called Kepler. It's a word by itself, but also it's also a niche, means Kubernetes efficient power level exporter. So the Kepler project is really comes to the goal of make the energy usage observable, meaning that we can report how much energy used by the infrastructure, by your software, and by your tenants. So if you if you are running a data center for your organization, or if you are using the cloud infrastructure, you may not just use it for a single application or for single tenant. Chances are you're probably going to use the same Kubernetes clusters for multiple tenants in your organization: finance, IT, logistics, marketing, things like that. And each of the departments may be accountable for what they use in terms of energy as well as the financial resources. By bringing these metrics into the picture, the end users will know, wow, this is how much I use, and what's our carbon footprint look like. So that is that's very important in understanding how much people can use for using our projects. Once Kepler makes this available, the next step is if people want to take actions, we want to give them the opportunities to optimize the workloads so they will use less energy. So we do that in two ways. One is called scheduling, the other one is called scaling. When we are making scheduling decisions, meaning that when we have new workloads or new applications to be started in the cluster or in the cloud environments, in the Kubernetes environments, how can we place a workload in the best node, best servers that can serve this workload most energy efficiently? Believe it or not, even though this may look counterintuitive, but it's in science, people discovered that you do not linearly pack the application and get the same use the same energy. A certain CPU utilization, the energy usage may be higher than lower. For example, if you are running the CPU at 70% utilization, and if you add 10% more utilization, the 10% more probably going to use more energy than previously stated, from 60 to 70%. So that means we have to consider the characteristics of the servers, especially the CPU and the cooling environments, to anticipate this nonlinearity and make a smart decision to place the workload in the equipment on the server that will serve the workload more efficiently. So that is in a nutshell of how scheduling works. The scaling works in a different scenario. So it's that if you already have your application, for example, the database or the web servers running in the environment, how can we make sure the energy used by the application can be minimized without sacrificing the performance that they are delivering? So one of the quick ways to do that is not all the applications serve their requests on the consistent basis. In the daytime, you're probably using the database server more than at night, right? So let's just say if in the daytime, we tune up the CPU frequency as the maximum. So you get the best performance, but you also using a lot of energy. At night, I just cut the frequency at half or maybe to a third of the maximum. So you are using much less energy, but you do not have to have a lot of workload to use. So you are not wasting you're sacrificing your performance because your demand is less. You're using less energy. So that will help a lot for the database administrators to be more efficient without having to sacrifice their availability. So that's kind of things we are doing in the number 2. Number 3 is really going beyond just compute. We are looking at the different scenarios. How about the storage environments? Data centers, not just for compute environments, they also serve storage. There's like Amazon, they have a huge storage services, S3, EBS, things like that. And we also have this accelerator called nowadays the AI becomes the big thing, right? So compute, AI, storage. This we could have other things, big things coming up. So we want to solve these use cases one at a time. So make sure this accountability and sustainability can continue in each of the scenarios. So that's why we are trying to have a longer roadmap to accommodate for all these scenarios.
Excellent. And we'll definitely get into AI in a few minutes. I have a few questions before that for you. We'll talk a lot about AI. But earlier you mentioned metrics and accountability. Why is having better metrics and accountability for energy usage so critical for businesses?
Yeah, so that's a very good one. So the metrics and accountability, they really has two bearings in my mind. One is this accuracy. The one is the transparency. The same way as we are looking at the financial statements, right? If you are getting looking at the company's financial statements using the same accounting methodology, you can reproduce it everywhere without having to rely on certain people's expertise or any of the black box kind of methodology to understand what is going on. It's completely transparent. So that's why we believe open source and open standards is the best way to communicate with the end users, how we measure things and how we come up with these numbers. So the metrics we are trying to bring up has two things. One is that we're using the real energy outputs people are familiar with, the watt, right? That is people are familiar with. And we also come up with the fine granularity. We come up with the workload level. So if you're running a database, we tell you how much energy you used by the database. If you're running web app, that's the number we'll come up on that application. This will give the people the insights into individual applications they are using. So that's why we believe Kepler is one of the top forefront runner in this space. We are giving them the granularity people like, and they can use this and different aggregation level. So if you want to see as low as the process level or container level, Kepler provided us a granularity. If you go up want to see at the tenant level, we also give you that aggregation granularity. So that is one of the things. So the transparency is quite critical because everything we offer is open source, not just the source code. The way we train the machine learning models, that's also transparent. We do not just give you a model. We give you the whole pipelines, how model gets trained, as well as the model in open source, so you can use it. You can also validate the model, right? You have very good accuracy in terms of the model's training metrics. So we believe the error range is less than 2%. I believe we have not got we have a different metrics. So one of the metrics called MAE, the mean absolute error. That's why it's it depends on which model are you using. Some of the models is as low as 1 or 2 on 50 and 80 watt basis, 1 or 2, that is less than 1%, right? And the newer models it has even lower error range. So we are really proud of our accuracy. So with that in mind, so transparency and accuracy. So I believe we are really doing the end users give them the benefit to using our infrastructures for their environments.
Thank you for that. So I have another question. So a lot of this is, if correct me if I'm wrong, taking place in public cloud. So how are you thinking about optimizing carbon footprint across other cloud types? So let's say someone has a hybrid cloud environment. How are you thinking about optimizing carbon footprint across those environments?
Yeah. So this is a very, actually, this is realistic questions in production, and people have been wondering that for a long time. So because not like the hybrid cloud is really on the premise that you can run your workload everywhere without have to worry about the infrastructure differences. And actually, means a lot of challenge. You have to hide the differences between different clouds and the private data center, the hyperscalers. So the differences are really tremendous. The infrastructure to bring in the commonalities has to be done in a very highly weighted way. So Kepler is no exception. We are entering this hybrid cloud environment with a lot of challenges in front of us, but we do have a solution. So our solution is that we actually go into this hybrid cloud the same way as the other softwares. We go into this public cloud. We take actions to measure the power consumptions of each of the data local instances, the machine types. So there are people can use the models we build to understand what's their energy consumption of the instances. And then by using these models from different cloud, we can just build up the holistic pictures when people are using the hybrid environments. And we are not just doing it in a hidden way. We publish our models on different cloud instances around the same time. So that's why if you are running on Amazon's cloud, for example, which is still undergoing, by the way, it's not done yet. We are building the pipeline to train the models on Amazon cloud. So we train on the cloud at our own expense. We get the models. So when you are using Amazon, this is the model you use. And consequently, we are using a different private cloud, and we are using a different machines that's different from the Amazon's machine. We are going to give you a different model you can use. If you do not have the model exact match to your machine, and we have actually the training pipeline, you can build the models on your environments on your own. So we give them the best options they can use without to reveal their configurations, the secret ingredients underneath. And they can do this without having to worry about their privacy. And we are also providing this open automation, and not just a lot of hard work. You have to type this command and run to get this result, and then copy this result to different inputs. We do all with a lot of automation to save people's time and reduce the entry barriers, so people can adopt our models and adopt our training pipelines.
It's great to hear that you're considering all these things and you're accounting for these different cloud types, because I'm thinking about it and I'm like, wow, there's a lot of companies who aren't just using one public cloud instance. Sometimes it's multiple public cloud instances in the multi-cloud, or sometimes they have that, like you mentioned, that on-prem or sometimes even off-prem in a co-location setting. But how do you manage all those things? So thank you for answering that. It's good for, especially for listeners who are dealing with infrastructure that's like that. It's pretty common as we see in our world as well. So shifting a little to the AI side, what everybody's really excited to hear about and talk about. As we were chatting before, we got into a little bit about AI workloads and large language models. So as we discuss those things, the growth of AI workloads like large language models, the adoption and energy use is usage is exploding right now. How big of an impact do you think AI innovation will have on cloud infrastructure, both positive and negative?
Yeah. So I do see this is a very interesting opening to a new era that we have never experienced before. Revolutionary speaking, this is just as we are entering, like I described in my career, I was able to get this containerization very early on. I was fortunately to get into this landscape and working with very exciting projects. But the AI, especially the generative AI, that's the quite different from all the computing norms that we have been used to for so many years. So speaking of the unique opportunities here, and also the unique challenge here is that generative AI is able to reduce a lot of overhead that we are used to before. So for example, I'm using the GitHub Copilot, and I see that give me a lot of productivity boost. So I was able to, I do not have to memorize a lot of details as I used to, and I can still get things done. That means a lot of productivity boost, means a lot of reduction in time, but also means the same thing. When it generates this content, you have to think about how much energy it's going to use. I read the article a few days ago. It was just there's some research revealing that if you ask ChatGPT, basically from OpenAI, ask you like 20 or 50 questions, the amount of energy and the amount of water for cooling purpose is tremendous. So like 20 or 50 questions, the water consumption is about 5 milliliters. That's quite a lot. And consider that there's billions of people using the ChatGPT on a daily basis, how much water it's going to use. And the energy is the same thing. So according to certain other research, in the beginning of the year, people estimate that ChatGPT used as much energy. I don't know what basis, maybe on a daily basis or on a monthly basis. Is equivalent to 175,000 Danish families' annual energy bill. So that's still early this year, and you see this ChatGPT gets more and more users, and I frequently get network errors on my ChatGPT. So that means the energy usage as associated with the popularity of the large language models is just tremendous. So we are facing this unique opportunity by enjoying the benefits of generative AI. But as the industry practitioner, especially focused on sustainability, I'm just really worried about the consequences of how much energy the GPT has consumed, and at the same time, the water that's going to use. That is something we have to take actions and look at how things are working internally to make sure that we are able to provide certain solutions to get our future in a better way.
Yeah, definitely. And then also considering ChatGPT is just one model. There's so many others. We were talking about Google with Bard and introducing Gemini into it. We saw some demos shortly a few days ago. So there are a lot of them. So as these grow and the adoption grows, and companies are adopting these AI workloads, do you think most companies properly measure and optimize for energy consumption of their workload, their AI workloads today? And if not, what do you think would need to change?
Yeah, so that is what we have been considering a long time. I think that also other companies or products are trying to come up with certain metrics to see how much energy associated with not just they have different metrics, but at the moment mostly just financial terms, as how many tokens you have consumed, because OpenAI charge by tokens. But there's no metric called token, per how much energy associated with each token. Providing that metrics is important, just like the same way Kepler works to provide you, how much energy used with this application. So you can potentially provide similar metrics, how much energy associated with that token, if you can understand how these tokens are produced. So by looking at the energy metrics, then the certain ways you have to get the application accountable for the generative tokens. And that will be one of the ways we can hopefully tame down the energy usage associated with the large language models. And not language models anymore. They have the vision models, the multimodal models, and that will be a tremendous explosive in the future. So the early we can take actions, bring these metrics available, the better chance we can reduce the energy and carbon footprints in the future.
That's great. So do solutions like Kepler leverage machine learning and AI to estimate things like energy usage and carbon footprint?
Yes. You actually speak both sides of Kepler. I mean, that's amazing because Kepler itself that's using machine learning in the heart of the project. We have built up the machine learning models, different models to estimate how energy has been used by. So give estimates based on different deployments, virtual machines or bare metal machines, how much energy used. So that's how we use the energy. To make Kepler available for large language models, so they can take actions based on the Kepler metrics. We are also working towards that direction. Oftentimes, when we say we give you some metrics and then you can take actions based on these metrics, you have to develop certain software. Developing software is not an easy thing, and make the software versatile and ubiquitous to make lots of things working takes the even harder level. So we are considering, can we use large language models to make the automation? For example, if I just the same way you have your series, right? So you can talk to series to set up timer. You just talk to it. So you don't have to run a program to set it off. In a very similar fashion, if you are giving for example, the ChatGPT prompts, reduce the energy for this workload, tune the configuration for this workload. If Kepler reports certain threshold, metrics that's about certain thresholds, chances are we can make that automation happen without do a lot of hard working in terms of programming or enablement. So once we are figure out what the tuning knobs are over there, and how we are able to connect Kepler with large language models, or potentially the ChatGPT or GPT-4, for example, we may be able to do these automations for organizations in a very seamless way, just like the way they ask questions on ChatGPT. They can ask the same question to reduce their energy consumption on their infrastructure by their software. So in a very similar way.
Excellent. And it's interesting to think about using machine learning and AI to help optimize for companies running potentially large language models and AI tools and applications in their workload. So it's like AI helping AI. It's kind of funny
true.
when you think about it that way.
Yeah, philosophically, that is a very intriguing story. We can just AI. That's
like Inception.
Yeah, that's right. That's right.
So what other opportunities exist to leverage AI for optimizing sustainability in your mind?
Yeah, so certain other things that we have been working on unconsciously, and I'm willingly, we forget a lot of things we can do. AI can bring up this back scene scenario into the front stage and help us to build up a lot of optimizations, as long as we are able to create the heuristics and instruct the AI to help us on this front. So the similar way, as we just mentioned, using Kepler metrics to do the automation, you probably can also tell the AI to build up a lot of other things as well. The productivity boost means we do not have to go to going to reading the software manuals, going to do internet searches and to find the answers. Language models probably already can give us a very quick answers when we type the question we are looking for answers. So that can also reduce energy usage in many ways. So for example, when we are engineers, especially programmers, have questions, we go into different internet sources and analyze, ask questions, analyze the results, and then based on these results, we write programs. We will probably actually do this in a more efficient or an automated way to use large language models directly to produce what we need. So that's where, even though generating these contents requires large language models to use energy, but in aggregate, time for searching, research and then developing the software, in aggregate, I think using large language models may potentially have even better efficiency than do this in a manual way. In order to make this more streamlined, more efficient, I think we, as an industry, potentially needs to have more specialized model in certain ways. Specialized, for example, in software development, in coding. Specialized in managing data centers, deployments, monitoring, and bug fixing, things like that. By using this specialized model, we can improve the productivity and potentially in the same way we can reduce energy usage. And a specialized model, and this is still debatable, but I believe that specialized model is almost certainly smaller than the large language model. As the gigantic models, with trillions of parameters, we probably can use there's billions of parameters to have a specialized model. That is more efficient to use. By using everybody, like you see, specialists that you still look for mathematical advice. Right? If you are looking for generic practitioners, you probably may not get the same idea. So things like that have play a similar impact. So that's potentially the direction I'm looking for, and hopefully we can just generate more sustainable usage of AI models in the future.
That's a great answer. So some more questions for you around that. Earlier, you had mentioned scheduling and scaling. Are there opportunities that exist to leverage automation and machine learning for scheduling and scaling as it relates to like energy efficiency?
Yeah, so that is very technical, but I believe this has a lot of interesting impacts on the audience. So on scheduling, we are really looking for at least two machine learning algorithms or techniques. So one is this, because scheduling has a lot of things to do with time series data, how the jobs are arrived and what's your projected job arrival in the future. So there's a RIMA, I forgot the exact terms. It's basically on time series forecast based on previous just short history or long-term history on the patterns that we are looking for. You can project how much traffic that will come in, in terms of number of requests, number of job arrivals. That's the one thing. The other thing is based on estimates of the energy consumption or capacity availability in the existing computing environment. That and projects on these arrival rates, what could be the best combinations. So things like that will play a long way. So on the scaling side, really that's a thing called reinforced learning, right? Because scaling, you probably don't know how to tune in the first place. Too much CPU, too much memory. That's for a job. That's the configuration work right for the configuration for the application. You will probably want to tune the CPU utilization or the CPU usage a little bit. See what's the feedback and what's the consequence. Using that as a feedback for the next round of tuning. So that's so-called reinforced learning. If the tuning is good, which means we get a better incentive to go into the same direction and make a next step tuning based on the same direction, then we are seeing the even better results, and then we're going to continue that path. So this reinforced learning really is in many ways has been used by AI models, just like the AlphaGo, the Google Deep Brain used to beat the human Go player a few years ago. Yeah, so that's based on the idea. Comparatively, the Go player, the machine Go player has played the game many, many times, and each time learn from the mistake. So that's trying to improve yourself. So we are using the same algorithms in the scaling decisions.
So as we're talking about AI, and sustainability. Those things go together, and you've explained very well how the opportunities exist. A lot of our listeners potentially, and a lot of businesses in general, are also looking at the cost side, cost optimization. What are some opportunities as it relates to sustainability, or what are some benefits as it relates to sustainability and AI that will also have impacts on cost? Because we know cloud cost optimization is a big topic right now. Sustainability is very important too. Where's that intersection? Can you tell us a little bit about that?
Yeah, I think that's a very practical question. And I do see these questions has been coming up on as greater frequency than before. Because sustainability means two things. One is the energy cost. Right? It's a direct cost to you. The other one is the food or carbon cost, which may not be visible in certain places. Depends on the geographic locations in the world. You probably see these things more prominent than the other places. For example, if you live in the European regions, there's the carbon credit market. The pricing, there's a certain thing called there's pricing and there's a quota, right? So in order to get your quota, you have to go to the carbon credits markets and to buy the quota. And that means financial cost. And then once you have this quota, you have to use it consciously, right? Those to waste the quota. And then that's going to included in your cost models, how the company will operate, how to distribute the quota within different organizations. And certain operations needs more quota than the other. And then the financial resources needs to be adjusted on this basis. So that's the third way is the valuation. So as we are looking at the financial markets, they are looking at the ESG investing, right? Environmental, social, and governance. So the ESG environment, it has been up and down, but I see this as a continuation. That investors, you are looking at your ESG scores when they invest in your business. So if you are doing well on your social side, on your environmental side, on your government side, you'll probably get some more investors interested in you. So that's where potentially boost up your valuation in the market. So I do see that as free capital market. This is as an incentive for the organizations, for the companies to drive up their social, economical, and also environmental ratings. So I think in conjunction of all these factors, energy. Actually, we are paying more for energy nowadays than before. I should see the utility charts, and over the course of the last 3 years, the energy price in the US has been increased quite a bit than past 2 decades. The same thing in the European market. So the energy cost, the carbon cost in terms of quota and financial credit, and also on the company's valuation. So these 3 factors, I think, will play a very important way in our future plannings.
Yeah, definitely. And it feels like it could be an episode of its own. We could probably talk about this all day because there's still the aspect of government regulation that's probably going to come along with some of this. And you mentioned Europe a little bit and some of that. So who knows if that comes to the US or other regions around. So it's very interesting thing to consider. In the spirit of looking ahead at things, what do you see as some major challenges that still need solutions around cloud infrastructure sustainability?
Yeah, I think the biggest challenge is regulation. Right now, there's no guidelines from our energy department. What's the metrics for measure the carbon footprint of software systems? There's no defined ways to measure that. If you look at the guidelines from at the energy department, the EIA, or some other government agencies, you will find references how much carbon footprints associated with different fossil fuel. So there's a very distinct, very straightforward guidelines over there, but you do not find guidelines on software. So that is one of the things. So as a practitioner, I see there's different ways people are inventing in the industry to try to come up with certain methodology and certain standards. This does not help our industry very well. Some methodologies, based on their own understanding, make sense, but may not be applicable to other applications, other scenarios. So if there's a transparent and open standards way, people can measure, unequivocally, this is how much I measured over here. That can be transparently reproduced by other practitioners on different environments with the same number. So that should be the way that we should be adopting. Once we have adopted ways of measuring and evaluating, then we probably can sit down side by side to report our carbon emissions and also see how we can benchmark against the industry. Right now, because we are lacking of these standards, lacking of this methodology, we are not able to do that. So if I report in my carbon footprints, hypothetically, let's say 100, right? People, we are using a different tool and based on a different number, like it's 500. Is 500 better than 500? 100 better than 500? It's a question mark. So we do need a standard. And hopefully our industry or our governments or in general, our society can come up with such standards so people can use it. So I think that is as a number one challenge. The number two, in my opinion, is the availability of such tool. So public clouds has potentially, I do not have the numbers in front of me, but I suspect that in general, the public clouds, the hyperscalers, the top three hyperscalers, probably generates the most, use the most energy, and even they are migrating to carbon zero emissions. They still have a lot of environmental impacts, the water usage, the recycling. These are the things. Hopefully, they can provide to the end users. So as the end users, we are using their service. We can take their inputs and make sure that we are, doing a very conscious thing to reduce our own footprints by using their service. So the public clouds hopefully can provide us the tools and the metrics that we can use, and also same standard way. Right? Not that Microsoft provide metrics, Amazon provide different metrics. That is not comparable. So so these are kind of a chain reaction. Without a common understanding, common standards, then these public clouds probably won't be able to provide these metrics. But on the other hand, these public clouds can drive up the formation of these standards. Right? There's actually initiatives and organizations, for example, the Green Software Foundation. There are certain projects over there trying to drive up this correlation between the public clouds to come up with these standards so we can have a transparent and coherent and consistent ways of viewing our carbon footprints as end users. So I see this as the top challenges we are facing nowadays.
And that's very interesting, those challenges and the organizations you mentioned. Where would you see them, where would you like to see them, those organizations collaborating more on these issues? Like what do you see them doing to get around? I know you mentioned there's lack of standards and the public cloud providers understanding their usage and reducing their usage. So where do you see organizations like the ones you've mentioned collaborating more on these issues?
Yeah. Right now, the common things among all these public clouds that they're using a lot of open source software. And to that standards, if they are also open standards, transparent open source, and also open discussion, that will open up a lot of opportunities. So if they can use, develop or adopt open source projects for the metrics, that's even better. And to that end, I have a biased view because hopefully I can, Kepler can be adopted in that way to provide, or the methodology developed for Kepler can provide, any values to that direction. So we do hope the open source, open standards, and transparency are the drivers for the public clouds to come up with the solution for our society and for our end users.
Nice. And you got a lot of energy when you talk about these things.
Thank you.
But I got another question. What gets you most exciting about the future of like sustainable cloud initiatives and the technology you're working on? What gets you really excited about those things?
As an engineer, I think my excitement comes from the way that we are able to use the latest technology in developing our technology stack, a software stack. So this is, if you're looking back the methodologies, it's not the what we are using is not quite new. The research institute has been working on energy measurements of software systems for many, many years, but they are not using the best technologies up to date. So we are using the latest technologies. Kepler using the eBPF, which is a new thing in Linux ecosystem, and it excites the community quite a lot. And once you say we are using eBPF, people just, this is the project, I can jump in. And then we're also using machine learning, and we are not just using the simple models. We support quite a complicated models, to be honest. So like I just said, we started with linear regression, which is still a model of itself, but we are moving on to more sophisticated like XGBoost models. And that makes people, wow, if I learn XGBoost, the machine learning, we can use in Kepler, right? So that's kind of technology excitement, using the latest technology. That's kind of exciting thing to us as accomplishments, and also things to motivate people to adopt our projects. So that's why we feel really lucky. The second thing that makes us very enthusiastic is to see that day to day, we see new questions on GitHub. People ask questions, why this thing is not working and why this is helping them solve their problems. This kind of confirmation and reinforcements that we are actually developing something people use. When they report problems, that means they're using our products. So that's kind of thing. You are not working on something with no end users, with no adoptions. Problems is actually our friend. Bugs are our friends, and issues are our friends. Without problems, without bugs, we are working on a dead project. So the more bugs we see, more issues we see, we are, I guess, very excited. And the third thing is that, as more we are working on, we discussed this earlier. We are working on a number of new cloud environments, server environments. Getting hands on these new environments also makes our life as an engineer very exciting too. A little bit understanding of how cloud works and how new hardware works. That is a new knowledge to us. As you keep refreshing your knowledge, you feel gets rewarded. So that's unlimited. If I can list like 10 things, I probably can count my all fingers. Maybe I can use it in my toes to add more things. But I feel like as engineering day by day, we get a lot of fresh energy from developing the products and learning new things.
Yeah, I love the passion and the excitement around it. I could tell you really enjoy what you do. It's great stuff. So I'm going to wrap it up. We're going to ask you one last question, and we've had a great conversation so far. So if there was one thing that you hoped people listening to this episode today understood, what would it be? Just one thing to take away.
Let's see. I probably want to stress that the open source and open discussion, open standards, transparency, and being openness. That's probably that's probably the being openness is most important, right? So you probably have the best idea, but if you are not opened up this idea, you may not find your audience, people who support you, and you may not find criticisms. One great genius may not have the best ideas to cover all the scenario. So open it up, let people hear you, and let's come up with discussions. That can get a better impact, a greater impact, and better futures. So if people pay attention to what we have discussed today, let's say be open. That's probably the most important.
Excellent. Well, Huamin, I want to thank you for being here today to speak with us about sustainability, cloud infrastructure, and all the efforts going on in your role at Red Hat. It was a great conversation, and it left me and hopefully our audience with a lot to think about. So thank you for joining us today.
Matt, it's always a pleasure, and I love your giving us the opportunity to share our thoughts, and hopefully it can give our audience inspirations and passions. So to explore the sustainable ways for our future generations.
Excellent. And the area of sustainability as it relates to the cloud is only going to get more important from here with rise of things like artificial intelligence adoption. So if listeners, you want to follow Huamin, I believe you're on X and LinkedIn, anywhere else, any other channels you want us to mention?
Yeah, we also have the GitHub Slack channels. We have Kepler has its own Slack channel. We also are present on the CNCF Slack channel. That's a Kepler project channel over there. So you can always ask questions, share your passions, and the most important, join us developing a better products for the future.
Yeah, we'll make sure to link to some of those in our description of the podcast episode as well. And also for listeners, subscribe to Cloud Currents. Feel free wherever you get your podcasts to see all of our conversations on the latest innovations in cloud artificial intelligence and where they intersect and connect. So we look forward to seeing you again soon, and thank you for listening.